Hi, and welcome to the pre-calculus notes for inverse functions 3.3a. So to find the inverse, we're going to follow a couple steps. So we're going to take the equation, and if you have it in function notation, you're going to replace that with y. So for this equation right here, you have function notation f of x equals 5 minus 3x over 2. We're simply going to take that f of x and change it to y. So you're going to see that down here in pink. I've written y equals 5 minus 3x over 2. Okay. Step number 2, you're going to interchange the roles of the x and the y. So you'll see in the very next step, where I have y, I wrote x. Where I have x, I wrote y. So you just kind of flip-flop those two variables. Step number 3, you're going to solve the new equation for y. So you're going to do inverse operations, just like you're in pre-algebra, until you get the y by itself. Okay, so for this one, since this side is being divided by 2, we're going to multiply both sides by 2. Since 5 is being added, we're going to subtract 5. And then since the y is being multiplied by negative 3, we're going to divide by negative 3. And we end up with this equation, y equals 2x minus 5 over negative 3. Okay, step number 4, you're going to take that y and change it back to the function notation, but you're going to call it the inverse of f of x. And then you can verify that they plug into each other and you get the same answer, x. Okay? All right, let's look at another one. All right, so we're going to find the inverse of the function of x equals 2x minus 9. So I'm going to swap out the fancy function notation with y. Then I'm going to swap my variables. And then I'm going to do inverse operations till I get the y by itself. So since 9 is being subtracted, I'm going to add 9 to both sides. Since the y is being multiplied by 2, I'm going to divide by 2. And I end up with x plus 9 over 2 equals the y. So I just change it back to function notation and make it the inverse. Okay. All right, for g of x equals 2 over x plus 3, I change it to y notation. Then I swap my x and my y. Then I do inverse operation. 3 is being added, so I subtract 3. Then I set it up as a proportion. Couldn't think of that word. And make that x minus 3 to a fraction by putting 1 in the denominator, and then I do the cross product. And then I multiply both sides by 2. And when you multiply by both sides by 2, you get y equals 2 over x minus 3. Then you just swap it back to function notation and take the inverse of the g of x. All right. Let's try a slightly more complicated one. Let me shrink this just a little. There we go. That's a little better. All right. So for the h of x on the left, equals 4 times x to the third minus 7. So I swap the h of x for y. Then I swap my variables. And then I'm going to do some inverse operations. So I'm going to start by adding 7 to both sides. Then I'm going to divide both sides by 4 here. And then the inverse operation of third power is third root. And then I just swap back to function notation and have the inverse of h of x equal to the third root of x plus 7 over 4. Okay. M of x equals the fifth root of x plus 6 minus 7. So swap this out to y notation. Then switch my variables. And then do inverse operation. So the first inverse operation is to add 7. And then the next operation is the fifth root. So I'm going to take both sides to the fifth power. And then 6 is being added to the y. So I'm going to subtract 6. And I end up with y equals x plus 7 to the fifth power minus 6. And then swap it back to function notation. All right. F of x equals 4 to the power of x. So I swap out the function notation for the y. Then I switch my variables. And then since I have 4 to the y, I'm going to take the log of both sides. So I want log base 4 of x equals y. And then I can change that y back to function notation. So the inverse function of x is log base 4 of x. On the right here we have g of x equals the 7 to the power of x plus 3. So change it to y notation. Swap your variables. And then do inverse operations. So subtract the 3 first. So you have x minus 3 equals 7 to the power of y. So we're going to take log base 7 of both sides. That leaves us with the y for this side. And then log base 7 of x minus 3. And then we just swap it back to the function notation. All right. On the left, we have h of x equals log base, is that a 5? Yeah, that's a 5. Looked like a 3 for a second. Okay, log base 5 of x plus 8. So we're going to change the function notation to our y. Then we're going to swap our variables here. And now we are going to write this in exponential. So I can take this 5 as my base right here to the power of the x. Usually it's on the other side, and that's going to be equal to y plus 8. Now to get the y by itself, 8 is being added, so we're going to subtract 8 from both sides, and we end up with y equals 5 to the power of x minus h. And then we just change it to the function notation of h of x. So it's inverse h of x equals 5 to the power of x minus 8. On the right, we have n of x equals 2 times the natural log of x. So we're going to change it to y notation. Then we're going to swap our variables. And to get this y by itself, we have being multiplied by 2, so we're going to divide both sides by 2. And then the natural log of y, we're going to change to e to the power of x being divided by 2. And that's our answer. So we're just going to take the y, switch it back to function notation. All right. Okay, so this is a review problem from before the test. So it says Joe invests $5,250 in a bank account with a fixed annual interest rate of 3.5% compounded continuously. What will the account balance be after 10 years? So the equation for continuous is A equals PE to the RT. So P is where we plug in the principal. So the principal in this case is the 5,250. Then we have E to the power of the rate. So the rate here is 3.5%. So I'm going to take that decimal and move it 2 places to the left. So it should be 0.035 times the T, which is time, and they tell us it's 10 years. So I just plug in a 10. Type this in the calculator. If you don't know how to use the E button, let me know. I can show you where it's at on your calculator, or you can use it in Desmos, and you should get $7,450.10. All right. And the last example, Anne invests $8,000 in a bank account with a fixed annual interest rate of 5.25% compounded continuously. How long will it take Anne to double her investment? So if you double her original investment of $8,000, you get $16,000. So we're actually going to take that $16,000 and plug it in for the P. Sorry, in for the A. So that's the number over here, but the P we know is 8,000, E to the power of 5.25%. So we're going to move that 2 places to the left, and it'll give us 0.0525. The answer that we want is T, time. How long is that going to take her? How long will it take Anne to double it? So we're going to divide both sides by 8,000. So we have 2 on the left. The 8,000s cancel over here, and we're just left with E to that exponent. So we're going to take the natural log of both sides. And on the right, that leaves us with the 0.0525t. So we're going to divide both sides by that decimal. And if you punch that in your calculator correctly, you're going to get 13.2. That's how many years it's going to take for Anne to double her money.